Okay, so let's look at some key things that we have to consider when it comes to your data analysis. You want to learn data analysis, how to use the software, right? There SPSS, SPSS, R, Python, any of the softwares at all that you want to use to analyze your data. We have some foundational things that we must be aware of. And I think if you have those foundational things, it will become very easy for you to appreciate the data analysis in this form. Okay. There are perhaps things that you're already familiar with. So it's just a revision. And also know how you can juxtapose them when it comes to into the area of research. So before you analyze any data, the thing that you have to talk about is the measurement of variables. How did you measure the variables in your case? For each of the variables that you are considering in your study, you should know how they are measured. Okay? You should know how each of the variable was measured. You should know how each of the variables was measured. And we have at least 4 levels of measurement, as you know. The first one is what? At the nominal level. Second one is the ordinal level. Third, interval. And then the fourth is the ratio. So when you measure any variable based on these criteria that we are talking about, they also give you data. So if you measure something, you collect data about it, is that not it? So let's look at what, or the nature of data that this will also give us. Okay. So if you measure things at the nominal level or at the ordinal level, you're likely to get discrete data. Discrete data. Okay. Then if you measure things at the interval or at the ratio level, then you can get continuous data. So the software, whenever it is analyzing anything, it will ask itself, am I dealing with discrete data or am I dealing with continuous data? It will ask itself, am I dealing with discrete data or am I dealing with what? Continuous data. Now, if it is able to know it, then it will tell you what kind of tools or techniques in the software that you can use to analyze the data per your objective. Now, so that is the first one. But we all know, you understand this, right? So we don't have to go over. Okay, this is so the next thing that will also inform your data analysis is your objectives, the research objectives. The research objectives, because it's the objectives that we are going to analyze the data to achieve. Is that not it? So if you don't have researchable objectives, you end up wasting your time. You'll be sitting in front of your laptop with your software, you can't use it for anything. So you have to get objectives that are that you can analyze. Let me put it that way. So you must get your objectives. So these objectives should be manipulated by statistical technique. So if you have objective and you cannot use the software to run it, can you achieve the objective? So it is very, very important that when you are setting your objectives, you ask yourself, is this objective, is this something that the software you can apply statistical technique on it to analyze it? If you're able to see through the various techniques and you identify the one that will help you to analyze that particular objective, then it is good for you. So make sure that you consult your objectives very well. The other time, those who went through the grad coach, went through, right, you know that we have levels of objectives. For the sake of our newcomer, let me just reiterate some of the levels. So if you want to set research objective, we can set some to look at for what? State of affairs. Okay, so we write it. Some of the objectives could be set to look out for state of what? Affairs. How things are. And if you set objectives at state of affair level, normally you use descriptive statistics to analyze them. So you want to look at degree of effectiveness of the use of computers among students. You use mean and standard deviation. Or if you use nominal scale to measure that one, you can use yes and no, and therefore use what? Frequency and percentage. You get it? So if you really want to get a snapshot of an event that is happening, then you have to set objective at state of affairs level. At state of affairs level. State of affairs level. Then, from state of affairs, you can set objectives to look at for relationship. So relationship-based objectives. So we have the state of affairs, and I said you have to use what? Descriptive, right? You have to use descriptives. Then we also have relationship-based objectives. So in your research, you can also look at for relationship between some variables, relationship between income and expenditure, relationship between attending this class and you passing your statistics. You can look at that. Relationship between teaching, relationship between teacher's provision and teacher performance. So you want to assess the relationship. And when we talk about relationship, your mind should go on correlation. Correlation. Either parametric or non-parametric. It doesn't matter, okay? What we have to do is that as soon as you're talking about relationship, then you're talking about correlation. Then you can have another third category of objectives. The third one is what we call the what? Impact or effect what? Or influence what? Based, they mean the same thing. Based objectives. When you set objectives, you want to look at how changes in one factor influence the changes in other factors, or how one variable predicts the other. Then you are using using that kind of impact, effect, or influence-based kind of what? Objectives. So with that one, what kind of statistical tool can you use to analyze them? You can use multiple regression. Okay. You can use multiple regression. What else? Binary regression. What else? Yeah, whether you use multiple or binary, it depends on the way. It depends on how you measure the variables. So you look at that. We also have logistics, right? We also have, I think, and I said structural equation modeling, right? So we can use structural equation modeling for impact or influence or effect based kind of objectives. You can use that. Then from that objective level, where else do we go? Intervening. You have set objective impact of this one on this one. But we have other third factors that may come in, and that is our moderators, mediators, and controlled variables. So we call them intervening based objectives. And so that one we have mediation, we have moderation, and then we have controlled analysis, where you can hold certain factors constant and still estimate the effect of one factor on the other. Okay, so these are the major things that we are going to consider. But when we come to the SPSS, you will do the set alongside, okay? So you will appreciate it well. Don't worry. So when we come to the SPSS, SPSS also has its own languages. Remember, when we are doing moderation, mediation, and all those things, we are not done with all the objectives, okay? So these are the fourth one. Then the fifth one is what? Test of what? Test of difference. So when you want to look at difference between male and female on the academic performance, and so you can use independent sample t-test. You can use ANOVA, you can use ANCOVA, and the rest. Is that not it? So those things are also there. Difference, test of difference, sorry. Test of difference based objectives. Okay. Test of difference based objectives. So that one, if you want to look at differences in academic performance, as I said, between male students and female students, you are comparing them. So you can use the independent sample t-test. When the grouping variable has more than 2 groups, then you can use what we call one-way ANOVA, right? So ANOVA is there. We also have ANCOVA. We also have MANOVA. We have paired sample t-test and the rest. They are all there. So they all fall under the category of t-test. So by the close of the day, I'm going to teach you how you use the software to analyze all these kind of objectives that you may set in your research journey. Because these are the major type of objectives that will come. Now, if you go into the software also have its own language. And that must achieve alignment with this one. So in the software, it will treat interval and ratio variables as continuous or scale. Okay? So if you enter the software, if you measure something at the interval or at the ratio level, it will see them as continuous or scale. Okay? If it is a smart PLS, it will see them as metrics. Okay? Metric data. Okay. But in the SPSS, it will see it as what? Scale. So all the things that we measure at the interval and the ratio level, SPSS will call them scale. But if you go into smart PLS, it will call it what? Metrics. Okay? Or metric. So if you go to smart PLS, so you know what I'm doing now? Yeah. Good. I'm doing the dual kind of thing. I mention here, the same thing. Okay. So, if you measure them at the interval and the ratio, you see, SPSS will call them what? Scale. If you go to smart PLS, you call it what? Metric data. But it will recognize the districts either as nominal or as what? Ordinal. The software will still remember them as what? Nominal or ordinal. But when it comes to interval and ratio, it will call them what? Scale. That is what I want you to appreciate. Okay? To call them scale. Now, when you are using the SPSS, it classifies the data analysis into 2. It classifies the data analysis into what? 2. When you are using the SPSS to analyze the data, okay, it classifies the techniques into what? 2. We have what we call parametric, and then non-parametric. Parametric and non-parametric. So if you select any two, you have to ask yourself, is it parametric tool or non-parametric am I using? So let's look at what the parametric tools are and some examples. When you are using parametric tools or techniques to analyze data, it means that you have to make certain assumptions. If you violate those assumptions, you cannot use those tools to analyze the data. parametric, they believe that we must adhere to stringent assumptions. So if you violate the assumptions, you cannot use them to analyze the data. You get it? For instance, if it is regression, I have appointment with her. But unfortunately, I'm meeting this one, so tomorrow is when?
Tomorrow is Sunday.
Tomorrow is Sunday. Tell her to come tomorrow 4 o'clock.
Tomorrow?
Yeah, 4.
4.
Okay, so parametric techniques, they require that you make certain assumptions, okay? If you violate those assumptions, you cannot use them. An example is multiple regression. You look at all of them, but I'm just giving you some examples. If you do multiple regression, we have certain assumptions, right? There shouldn't be multiple linearity in it. There shouldn't be autocorrelation in it. The sample should be randomly selected. The sample size should be adequate. There should be homoscedasticity and all those things. So all those are key assumptions that we have to check. It is when you violate these assumptions that you jump into the non-parametric alternative, if it has. You get it?
Yeah.
So if you choose any of the techniques, ask yourself, is it parametric or non-parametric? If it is parametric, then you have to come and test the assumptions to see to it that all the assumptions have been what? Met before you proceed to test that particular objective. For non-parametric techniques, they also come with less stringent or even no assumption at all. Okay? They come with less or no stringent assumptions under them. And therefore they tend to be more user-friendly. Is that not it? It's very easy to use them. Okay, so that's just the opposite of parametric tools. So if you, let's mention some examples here. Okay, so if we have the Pearson correlation, it's parametric. Partial correlation is parametric. Multiple regression is parametric. Replica multiple regression is parametric. Logistic regression is parametric. Independent sample t-test is parametric. ANOVA is parametric. MANOVA is parametric. ANCOVA is parametric. Okay? You have a host of them. You look at all of them. Then we also have some non-parametric tests that we can talk about. Kruskal-Wallis tests, Friedman tests, Spearman rank order correlation. Remember that?
Yeah.
Now, structure equation modeling. There's non-parametric alternative.
So not alternative.
Yeah, it is non-parametric alternative to regression. Are you surprised?
That's right, yeah.
Okay. But it still requires that you make some of the scientific assumptions in a parametric test before you can apply them. Okay. So these are some of the things that you have to look out for. If you want to choose any of the techniques are the things that you use or the tools that you use to analyze the objective. So if you set objective to look at relationship, what technique can you use? If you are settling on a technique, ask yourself, is it parametric technique or what? Non-parametric technique. That is what you have to ask yourself. If it is parametric, then you have to demonstrate and analyze to get the test the assumptions under it before you go on to what? Use it to analyze your objective. But many a time you go on with objective straight. You go on with objective straight. And so that is that. Okay. Any question?
Okay, you said we'll go to them individually.
Yes.
So the one we enter there.
Okay. So that's fine. So assuming that you have collected your data, just like the data file I've given to you. When you get your data, what's the first thing you have to do with your data?
After you have collected them.
When you collect your data, what is the first thing that you have to do? You enter your data into your software, right? And you have your complete, so you do the data cleaning and all those things. It's different from data manipulation. It's what? Data cleaning. And when you are cleaning your data, you look out for outliers, you look out for missing values and the rest. And the errors that might have occurred in keying in the results. Make sure that you screen the data mostly using descriptive statistics. For instance, if you want to detect outliers, you can run what do you call it? Frequency. Is that not it? It will give you, or you can run mean, and it will give you the maximum and the minimum numbers so that you know if you use interval scale to analyze that particular variable, it will be able to expose them to you. You can run descriptive to also look at non-responses or missing value. Is that not it? If 200 people have answered and you run frequency of it, those who didn't enter, you will see them. Is that not it? Those that you have entered wrongly, you can also see. So when you get the data file, or when you get your data, you do your coding, then you do your data entry. And at the end of it, you clean your data. You clean your data. So we are believing that the data file that I've given to you is cleaned. Okay? It has undergone all those processes. We have collected the data, we have done the coding, we have entered the data, we have cleaned the data. And so this is accurate data file. It's what? Accurate data file. So if you also get your data file, that is what you have to do. Make sure that you enter accurately the data that you captured. Okay. So when you get your data file, what is the first thing that you have to do? Remember, we are doing quantitative research, right? Where we are mostly looking at if we use, the example that we are using is, they use structured questionnaire to collect the data. So when you get the data file, the first thing that you have to do, after you have cleaned the data file, the first thing that you have to do is to come and check for validity. Validity. Okay.
Obtain the data file.
After you have obtained the data file and the file is clean, okay, what you have to do next, or the first thing you have to do is to check for the validity of the data. Because if you use questionnaire, for instance, to collect the data, you should be able to validate that the questions or the items that you ask are actually measuring the concepts or the variables that you are interested in. And so the first thing that you do is to go and compete for what you call validity. You understand? What do you have to do first? Validity. Okay. So we have so many different types of validity, but here we are talking about the one that you can use statistical technique to identify that indeed the questions are valid. Okay. Indeed, the questions are what? Valid. Now, before I go on, we test for validity not for variables. We test for validity for constructs. We test for validity for what? Constructs. So when you are doing a study and you have variables, individual variables, you don't test for their validity with the statistical software. Okay? So you can check the phase validity, you can content validity and all those things. But if it is construct, then you have to compete for this word, validity. And what is a construct? Have we any idea about what a construct is? Okay, let's see if we can elaborate on that.
I'm talking about and where define it. variable
What is a construct? It's a concept that can be measured by more than one variable. In your research, every concept that you cannot use one item to measure, but we have to add series of questions to be able to measure it, becomes a construct. So all constructs are variable, but not all variables are what? Constructs.
All constructs are variable.
Yeah. All constructs have variables in them, but not all variables are treated as constructs.
Okay.
In the context of your research. Okay, so when we talk about the construct, we are talking about what? Concepts that are measured by a collection of related variables. Let me put it that way. By a collection of what? Related what? Variables. And you will see that in the social science research, almost all the things that we target are considered constructs and not as what? Variables. Almost all the things are considered as constructs, not as variables. You look at them. So how do you check for validity? Okay. This one we are doing the theoretical base before we go to the practice. So the theory, make sure you understand it very well. Okay? So if you are using SPSS to do your analysis and you want to check for validity, we have two types of validity that we are going to talk about here. The first one is what we call exploratory validity, and the second one is what we call confirmatory validity. Okay, so when we are using SPSS, then we can talk about exploratory validity and confirmatory validity. And if you want to test this kind of validities, you have some techniques that you can use in SPSS to run it. When it comes to SEM, you look at it differently. Okay, so exploratory and confirmatory, let's look at the meaning. When you are measuring a concept for the first time, and you are developing the skill to measure that particular concept, then you have to do what? Exploratory factor analysis, or you do what called exploratory validity tests. But if you take existing skill, like the construct, maybe you are talking about employee satisfaction, you have gone and you have seen that Gideon has developed a well-accepted skill, then you pick it to measure that employee satisfaction. Then it is better you do confirmatory factor analysis, just to compare whether what Gideon found is the same as what you are also getting in your context of the study. So as to whether you will do confirmatory factor analysis or exploratory factor analysis depends on the nature of the skill that you are using in your study. Some research, they will tell you to do pilot tests. So pilot test is normally done to test for exploratory validity. Okay? And then when you go for the main one, then you can come and confirm. So if it is a well-funded project, they can let you do pilot testing to check the exploratory validity of the skill. But when it is finalized, after it has gone, you have finalized and everything is okay, then you come back and do what we call confirmatory factor analysis. So these are the two main validities that we are going to talk about. And we have approaches in estimating this kind of this kind of validities in SPSS. So that is what we want to have a look By the way, when we talk about validity here, what are we talking about? To test validity means what?
The variables that you have come out with, probably you are developing it, whether they can measure the cost of that.
Very good. So when you are coming out with skills to measure particular something, you have to ask yourself whether that skill is measuring that variable. But you are not the only person who places judgment on it. The people who also answer the questionnaire, it is their view that is also supporting your view. You see, you the researcher, you write your items and put it out there. If the people read through and they see that it is measuring it, it will confirm it. If it is not measuring it, then they will tell you that answer. Go back and redo.
Okay.
So it's just a confirmation from your sample's point of view. You have done it. You must get confirmation from all the people who also participate in the study. So that is practically, that is what the validity test is all about. I've asked questions. Now I throw it out there. The people must also give me something for me to also see if the questions that I asked are actually measuring what I intended to measure. And so that is what validity is all about. And we have so many of them. But in the SPSS here, we are going to look at the two. But when we use Smart PLS, cell, we are going to talk about discriminant validity. You can write them down because when we read there, I will just mention it as you are going. We are doing parallel kind of learning. Okay. So when you are using partial least square, you compete for what we call discriminant validity. And discriminant validity is measured by HTMT. Don't forget, it's measured by HTMT. Okay? HTMT ratio. Yeah, HTMT ratio. The ratio should be 0.85. Should be less than or equal to. Should be less than or equal to 0.85. Should be less than or equal to 0.85. Okay. Then you can also look out for what we call convergent validity. Understand? You can also look out for convergent validity. And the convergent validity is measured by what we call AV. Convergent validity is measured by the AV. AV should be 0.5 and above. Okay? It should be 0.5 and above. AV should be 0.5 and above. Don't get confused. I'm teaching you the same thing. I told you that SPSS is the same thing you're going to do yourself, but in different approach. So that's why I'm teaching the two concurrently. So when we reach the practice, you just click papa, and then you go. Okay. So let's come back to the SPSS. So we are going to look at for the exploratory factor analysis and complementary factor analysis. Let's look at some few things that we have to consider when we are doing exploratory factor analysis and complementary factor analysis. And I'm sure by now the differences are there. Is that not it? Between complementary and then exploratory, the differences are clear. So when you are doing factor analysis, there are certain things that you have to take note. And those are the things I want you to appreciate more. After your meeting with me, you will not be afraid of any statistics. Okay? Okay. So when you are doing factor analysis, there are certain things that you have to consider. Okay? First is the sample size.
That's what it's like, exploration.
Both exploratory and confirmatory. It's long time that I learned this one, sample size. Sample size. How many sample size do you need to be able to perform this? If you read some of the assumptions, I think you need a minimum of 400 cases. You need what? How many cases? 400 cases. Pilot, you testing your factor, doing factor analysis, both exploratory, you have to get how many cases? 400. Is it easy?
No.
When you were collecting for 30 cases, you got 31. How was it like? So if somebody goes and says, I've done factor analysis, and you check this thing, you should know that if you do not have to this, you can question the person on the sample size.
There should be a sample size of 400.
Yes.
Then
But
most people will not do factor analysis.
The guys didn't come.
Okay.
You want something else?
When I'm going there now, 500. Okay. So you need a sample size of what? That's too much. Then you need a sample size of 400. You ask a practical question. What if even the total population is not up to 400? Does it mean that you cannot still go and do factor analysis? Is that the case?
My brother, if you look at this book, the Palette, I saw somewhere that 150 or more.
Okay. 2016. Did that say Julie Palan who told me 2005? That it should be 400. So by now people are questioning yes, that's why.
Those are 150 cases or more. So
I'll give that book. I have the Julie Palan's book. The foundation for all that we're doing. I'll give it to you. So your sample size should be this for now. But what if the sample size is not there? Then you have to come and test for some assumptions. So you have to come and test for some assumptions. That we call sampling adequacy. Okay. Adequacy. Sampling adequacy. Come from the word adequate. So sometimes you cannot get the 400, but the sample that you have used, is it adequate enough to warrant the conduct of the study? You get it? So you have to come and check that. And there's a proxy measure of it. KMO, they call it KMO. So for you to get adequate sample size, your KMO should be about 0.5. If your KMO is above 0.5, if it's above 0.5, you conclude that your sample size is what? It's adequate.
Okay, if it's above.
Yeah, so assuming you don't get the 400, but you get about 150 or 90 or 100, and when we run the analysis and the KMO is 0.5 and above, you see that even though it's not up to the 400, it is what? Adequate enough for you to do the analysis. So if you violate this one there, if you violate the KMO, then you cannot go on with your factor analysis. You have to go and collect the data again, or modify the scale and then go and do it again. So I've given you some 2 things that you have to do. If it is not meeting that, what did I say? First, you can modify the scale and then go and collect the data, or you can collect more data.
So indeed, this 0.5 is sample dependent.
Yes, that's what we call Kenya-Meyer's measure of sampling adequacy. They want to tell us that it's adequate. Okay, then the next one is what we call Butler's test of sphericity. Yeah, I've not revised for a long time, but I will teach you. But let's test of what? Sphericity. Sphericity. Okay. We want the sig value to be less than 0.05 or equal. We want a sig value for the Butler's test of sphericity. The sig value should be less than or equal to 0.05. If you compute it and it is less than or equal to 0.05, we say that the correlation matrix is not identity matrix. If it is like this, we say the correlation matrix is not identity, okay? Identity matrix. And that is what we want it to be. You look at that, when you compute your sample, you will see that the correlation between the indicators, okay? The correlation between the indicators and the constant that they are measuring should not be zero. Should not be zero.
The correlation matrix should not be
identity matrix. The correlation matrix should not be what? Identity matrix. So if it is above 0.05, we say it is what? It will be the opposite.
So the correlation matrix is identity matrix.
It is, yeah, if it is identity matrix, it means that that assumption too has been evaluated. And you cannot proceed. And the same two options are still available for you, right?
Okay.
What do?
You can modify the scale, but you go for more data.
Good. So these are foundational assumptions under factor analysis. We have a host of other assumptions. You have to use random sampling or probability sampling in selecting your cases. Your pilots, do you select them randomly? Did you select them randomly or use convenient sampling? It was convenient or purposive.
But probably on paper it will be random.
On paper, that is unethical. As a researcher, we admonish that you do the needful. You do what is right. But on paper, they were randomly selected. Okay. So that is it. So these are assumptions under it. Apart from the assumptions, if you compute, if you get the main results, there are certain things you have to look at. Okay. So one, how many variables under this factor? How many variables can form a construct? You understand? You know the construct is made up of a number of what? Variables. How many variables are supposed to form a factor? Under this, you say there are 4. Minimum of what? Minimum of what? 4 variables should form a factor. The term factor is the same as construct. Okay? When I say factor, I mean construct. So the number of items, when you compute your factor analysis, the number of items should be minimum of what? 4. So imagine that you have adapted a scale or you have developed a scale and you have only 4 items. Or you have 3 forming that construct. Is it something? Is it right?
Maybe this one validated.
Because when you go and when you run, you have to delete some of the items. It will reduce the number and it can affect this kind of assumption. So it means that if you are forming a factor under the SPSS, then if you are developing your skill, you should have a reasonable number of what? Items under the construct. You have reasonable. So it should be 6, 7, 8, 9, 10, thereabouts. It's okay. It shouldn't be more 4 or less than that. So your construct, financial performance, how many items did you get?
3.
No. I'm not talking about the specified model. When you were designing the questionnaire, how many items did you use to measure it? Performance.
I use profitability,
Okay.
liquidity,
Okay.
efficiency,
Okay.
and then group results.
Group business. So they have money. Go and top it up. Because if you use this one to check for the validity, and one of them is not good, you have to take it out. And when you take it out, what will happen?
We'll pray for them, so they will hold you.
Okay, so that is it. Another important thing is that for any variable to be considered as a valid variable in measuring or contributing to measuring that particular process, for us to say that it's valid, it must have a correlation of 0.3, minimum of 0.3 with the factor.
Okay.
We are saying that 1, 2, 3, 4, you are forming this laptop. I'm saying that before we will say that we have a valid question, your correlation should be 0.3 with this particular construct. Other than that, you are not forming it. 0.3. You ignore the sign. Whether it is negative or positive, it doesn't matter, okay? Because you can have negative relation, is that not it? You can also have what? Positive relation, it doesn't matter. You ignore the sign. If the correlation of the item and the construct is 0.3, then we say that that item is valid measure of the construct, okay? We see that that item is a valid measure of that construct. It's a valid measure of that particular construct. And we will demonstrate this, okay? So 0.3 to 0.3 and above.
And above.
So 0.3 and above. But it's very difficult for you to get 1. So 0.3 and above. If the correlation is that, then we say that it's a valid what? Valid variable. Okay? Valid variable. Measuring that particular concept. Okay, so when we compute it, you check the correlation of that factor, so of that variable with the factor it is measuring. If it is above 0.3, we say it is what? Valid. If it is below that, we say it is what? Not valid. So if it is not valid, what do? You take it out. It doesn't measure it out. Very good. You take it out. Okay, so this is for SPSS.
Yeah.
Cell. So you know that we are doing the same thing here.
Yes.
For cell, your indicator loading should be, write it down. We are no catchers of Munkosi Amra. For cell, Yeah, if you are using smart PLS, for sale, your indicator loading should be what? 0.7 and what? Above. If it is not up to that, you delete it, okay? Remember, it's the same thing, but different approach.
Indicator loading.
Should be 0.7.
So with the indicator, we are looking at the various questions.
Various
So when you
questions.
take each construct measurement, how the question that you form.
Yeah.
So if it's less, if it's above 0, if it's 0.7 and above, then you maintain it.
Yes.
If it's below, you
You delete it. And the SPSS, if it is having 0.3 with the factor, you maintain. If it is below it, you delete. It's the same thing. And the SPSS, you need 4 minimum to form a construct. And the smart PLS, so 1 indicator is enough to form a construct. Yes.
Okay, and smart PLS, you need
The factor,
only
one variable can form the construct or factor. One variable can form the factor. One variable can form the factor.
that's better.
Wait until you finish your research and you specify your model and each of the factor you have only 2. You go and meet your supervisors and tell them that you can justify it. Financial performance. You go in and the financial performance is made up of only 1 indicator, income. Doesn't mean profit is not. You see, it's practical nature of it. Yes. So that is it. So apart from this one, it also tells us whenever you compute for your factor analysis, it also tells us something about common method bias. Have you heard of it before? Common.
So is it for SPSS or PLS?
All the 2. I told you I'm teaching you concurrently. So the earlier you arm yourself, the better.
Bias.
So for common method bias, okay. When you estimate your factor analysis, okay, there is what we call percentage of variance. If the percentage of variance is, what is the decision? Is 50% or less, then there is no threat of common method bias, okay, under SPSS, okay. If percentage of variance is less than or equal to 50%, less than or equal to 50%, then there is no threat of common method bias. And we are going to look at common method bias. It is relevant under this context to examine what it is.
So this one, so particular what does it indicate then?
So,
Is it the threat of common method bias?
common method bias. You know it.
What does it indicate then?
You will look at it shortly. So under SPSS, if you run your factor analysis, the percentage of variance will be less than or equal to what? 50 to avoid the threat of what? Common method bias. If you go to cell common method bias is measured by inner VIF. Common method bias is measured by inner VIF. Inner VIF. measured by inner VIF. Okay? And the inner VIF should be less than 5. Should be less than what? 5. Should be less than 5. If your inner VIF is less than 5, then there's no threat of common method bias. Then there's no threat of common method bias. There is no threat of common method bias. Okay. So let's look at what common method bias is. Remember, when you are formulating your questionnaire, for your financial performance, for instance, all the items are here, is that not it? And then you read them on 1 to what? 5. Common method bias may occur if people are responding to the same skill for the same items, where people will not read the questionnaire. So they will just be ticking. And that will bring what we call systematic error in your data. And there's what we call singularity. Okay, my RML is killing me, but I've managed. I've managed singularity. Okay, let's put it that way. Sometimes some of the variables you see that they will take one throughout. But is it really normal? Like we have a sample size about 500 people, and they are all taking the same answer. It can cause systematic what? Error. Central tendency, neutral, tick, neutral. It's because, you know, all the factors are measuring in particular, all these variables are measuring that factor. Is that not it? So people are more likely not to read the items, and that will expose it to what we call common method bias. So what can you do to avoid that? What can you do to make sure that if you have a skill, measuring a particular construct, people will read the skill well, and then they will answer. So if you tell them you tested for common method bias, they will ask you, my dear, what did you do to avoid the threat of common method bias? Say 1 or 2 and then we go. What will you do?
Is it after you've taken the data and you realize it or before?
So before you go and collect the data, there are some principles or procedures that you have to follow. You put them in place to avoid the common method bias.
So you can take them through the instrument and explain.
Very good. So in order for them to develop interest in providing you with genuine answer, you explain the content of the skill to them. And that can help them to understand it and not just take anyhow. So explaining the content is a procedural kind of thing that you can do. Or they call it ex-ante principle. And so they ask you, what are some of the ex-ante principles? Ex-ante principles. Did you follow in order to avoid threat of common method bias in your skill? I explained the content to them. What else? What else can you do?
There's no tendency to talk about, you know, some of the skill like 1 to 5. Sometimes we put maybe the center one, maybe neutral. Some people may want to stay away from the responding to, so they can stick to the neutral one throughout.
Very good. So in order to avoid that, you are rating, you take out what? The neutral. So that one we call it false skill. You don't give them room to settle on neutral. You have forced them to answer and respond to a particular kind of thing if they want to.
So meaning that before you reach out to them, you take up that one?
No, you don't even include it when you're designing the questionnaire.
So it's just like you have the assumption that can happen.
That can happen.
So you just
take it out. So instead of 5 skill, you can make it what? 4. And then they take what will give you a genuine response on the item. What else can you do? Have you seen how practical it is like? What else can you do?
Situations that they cannot read. So after you explain and maybe they give a feedback, you can also be the one doing the taking instead of them doing the taking.
Okay, so you can assist them, or you can get field assistance to help them in responding to your skill. Okay. Chairman, what else can you do? Apart from getting field assistance and helping them, what else can you do?
To solve this problem.
Okay, let me give you some. Ask them reasonable number of questions or items. The number of skills in each of them should not be plenty. Somebody pick a questionnaire and we have more than 100 questions to answer. My brother. Do you think the person will read all? Similar thing happened to me in one of my studies. But the study design was such that you cannot omit some of the variables. They are all important. The way I suffered. The reason is that if the numbers are many, then they have to spend 30 minutes, 40 minutes, 15 minutes to complete. It will disincentivize them. So you have to ask them reasonable number and yes.
Some will even when they pick their instrument first, they open to check. They are not put a page before they start. I administer this situation. I administer for teachers. And you know, with the teachers, I went and gave it to one of the students who was going to. Oh no, you know, man. Okay. So I think that one you can pause this program.
Yeah.
Because the student will just take maybe take the one side and go and give the teacher.
So you have to state that you also gave the questionnaire to the target respondents.
Okay.
You are supposed to give to teachers, the person goes to give it to students. Are they the target respondent? So you gave the questionnaire to the target respondents. And being the target respondent, it is known that they can provide you with the needed information that you need. Is that not it? They can provide you with that kind of information. Okay. What if you also take validated scale to measure the concepts? Is it going to solve some of your problems for you?
Validated scale.
Instead of you developing the questionnaire yourself, you take existing skill. Your questionnaire, did you get the things off head? Where did you get them from? So people, that's a validated skill. So if you take validated skill have been digged, has gone through the test psychometric analysis and they know that everything is okay. So it will help you to minimize some of the threats that may occur. So choosing an existing pre-validated skill is also a good way to minimize the threat of common method bias.
Is that?
I thought you are done.
No, please. I have to ask you.
Just one.
So hopefully next semester I'll
Good luck.
Okay. So if you take existing skill that has been validated, you're good to go. And yeah, you're good to go.
That one can solve, will not be lengthy.
Because they might have looked out for all the errors and they have already neglected some of the problems that will come. So you don't have much problem. Okay. What if you change the written skill? Some of them are agreements. some of them are efficiency, some of them are quality. So in one skill, you don't have to do everything, agree, strongly agree. No. It is when they detect that the written skills are the same that they don't even read.
So what you are saying is if, let's say, a particular variable, the questions, then you are using maybe 1 to 5, you shouldn't just use strongly agree to answer all the questions.
You can, for one skill under same skill, maybe financial performance, you can ask them agreements. But when you go to financial planning, you can look at effectiveness of financial planning. So instead of instead of agreement, effectiveness will come in, likelihood will come in, importance will come in, quality will come in. So changing the written skill can also make them more dynamic to refocus. And also, very, very important, that if you mention, people know that you understand what you're talking about, is that you have to negate some of the items, negate some of your statements, negate some of your items, negate some of your items. And in negating some of the items, if everything is positive, if they are all positively worded, for instance, maybe employee satisfaction. Oh, I'll come to work every day. Without this job, I cannot stay. I will work for this business. Is that not it? They are all in positive. Then you bring one. Tomorrow, if I get better alternative, I will leave. If the person reach that point, the person what? Pause and think. Before.
I think in my own, you made us
good. And it has been proven as more efficacious in avoiding this problem. We have a host of other S&T principles that you can follow. But I think the ones that we have discussed are practical enough for you to be able to avoid that. Okay. So these are the theories that we want to really learn about the beginning of data analysis. So we are going to the practical session, right? And I think by 15 minutes time we should be done with factor analysis. And you can interpret and you can do everything. For now, since you don't have the cell, you have the cell. Since you don't have the PLSM on your machine, you use SPSS. I have somebody who install it for you. So when you're ready, you come and install it and then you can run it. But by that time, I might have built the theoretical basis for you. So you don't have any problem. We just show you one or two things and then you are. We just show you one or two things and then you are on. Okay? Good. So that is it. Let's end it here.